Let us see another question about the use of lami theorem. So a particle P of weight 300 newtons is hanging in equilibrium by two like inextensible strings FP and BP which lie in the same vertical plane. String AP makes an angle 60, so this is the string AP, as you see makes an angle 60 with the vertical wall, and BP forms an angle theta with the horizontal. So you see that that's the angle. If the direction the string AP is, so they are giving us the direction the string AP, find the value of theta. So now I've sketched using and the direction BP using the diagram below. So that's they have sketched for us, and then I'm also sketching it there. Now here what you do, the moment if you want to get angles in lami theorem, you always use the horizontal and then the vertical line. So I have this. Now, if I draw a line here, a vertical line passing through this, like this, a vertical line. Remember, this one is having a certain force. This one, remember our weight now, they gave us our weight as 300, now this is weight. Then we also bring back the horizontal passing through that, like that, with the ease. So meaning the angles I want this angle, I want this angle, and I want that angle. So first of all, you know that this one is going to form a 90 degrees there. So if this is 90, it means that now here is going to be 30 degrees. And now if this is 30, it implies that here, remember this one is going to form also 90. So this will be 60 degrees, or this one is alternating with that, and this will be 60 degrees. As simple, that is the first part. So now you have this angle here. Remember, they are giving us the tension in the string AP. The tension in this string AP, they are giving us 120 newtons, and then this one, we don't know it is what we are looking for as T. Now, using that, is that from here up to here, so this one is alternating with this angle. So this angle is going to be the same as this. So this one is going to be theta. And remember, this is 90 degrees. So now, the question is going to be, how do we get the balance of the angle? Remember, the whole of this angle is known between this force and this. Now, between this force and this is known, because this is this is theta, we can ever get that. Now, the question is, what about the angle between this force and then that force? But I think that is the easiest to get. How? Because you see, the balance from here, the all of that is going to be from here to this is going to be 180 minus theta. Because if this is theta, then this is going to be 180 minus theta. So now I think this one we have also this angle here. So we have the whole of this, we shall add this plus this, then we have this and that. So meaning we have now everything. So this sketching that, let me sketch it here. That's what we have. We have that down, and also we have another force there. So this is our P. So they are telling us that this force here is 120 newtons. Then this force here, the weight is 300. Now they are giving us weight, not mass. If they give you mass, that's what you apply with G, the gravity. And then this is the tension we are looking for. Okay, now this angle here is going to be now, we are going to add theta plus 90 here. So it's 90 plus theta. Then this one here, we shall add, remember this angle here, we shall add 180 minus theta, then the 30 degrees plus that, and such there we shall get 10 minus theta degrees. So the whole of this is 110 minus theta degrees, and that will be the angle we have there. Now this one, for it is the easiest, which is 60 degrees. And there you can every you can use our lami theorem. How are we going to use it? You can see that T over 60, T over sine of the opposite angle, which is 60 degrees, T over the sine of the opposite angle. Then from there we have this T and that angle. Then we have the opposite. You see that the force we have is 120 20 over the sine of the angle, which is sine 90 plus theta degrees equaling to this, the opposite side of the opposite angle. And we also have now 300, and the opposite angle is that 300 over sine of 210 minus theta degrees. And I think you can definitely see that we have everything in there. So the rest I think is just substitute in there and then simplify. So this one I'm missing, this one need a pair where we know this angle. So we are going to use these two so that we can every get that angle. So from here you can see if I cross multiply, I have 120. I have 120. Okay, let me start with 300. Okay, 120 sine of 210 minus theta would be equal to 300. Then here I have sine 90 plus theta degrees. I think now we can every expand this using I. Okay, or you can every now separate this. And then you know that if I have sine n, you know that you can either say this is going to be 100 plus that angle in brackets so that you can easily get the angle. Or if you don't want that, you can easily expand it. So this would be 120 into now how expand sine we get sine 210 cos theta, then minus cos 210 sine theta equaling to 300. This will be sine, we expand this, sine 90 cos theta plus, the sine goes with the sine there, then cos 90, then sine theta. You know that sine 90 is 1, so here I'm going to, and cos 90 is 0. So we are going to be having that there. Then you can replace this sine 120, sine 210 is negative 0.5 because it's in the third quadrant. So here we have 120 into negative half cos theta, then minus, this one is this, and this is here, then cos is going to be root 3 over 2, but negative, so this would be negative root 3 over 2 sine theta equaling to 300, sine 90 is 1, so this would be cos theta, then cos 90, this one is giving us a 0. So that's what we have there. So what is common there? We can ably factorize. Okay, you start this a half, you can move out this a half here. So you see that this and this is going to give us a positive. So we have now the cos, we have the sine, we have this. So allow me to take this side. If I expand that, I'm going to be having now negative 60, this times this, 60 cos theta, then plus this and this I have 60 root 3 sine theta equaling to 300 cos theta. So when I take this side, I'll add, so I have cos 60 root 3 sine theta equaling to, when I take this side, I have 300, and we add it because we're going to add 60 cos theta, and you can every see we are going to get sine theta over cos theta, but you can every see it through direct, but I want people to get lost. Root 3. So start this one is going to give us our tan theta, which will give us, you see here we have 6, because this goes 6 root 3, and so therefore our theta will be tan inverse of 6 over root 3, which you can simplify, but that's not the order of the day, which is going to be so this one is giving me 73.9 degrees to 2 decimal places. So after getting that, now I think we can come and get our tan from there. From our T, this is part A, then our part B, our T now over sine 60 degrees would be equal to 2, now 120, and all over sine 90 plus now 73.9. So start from there, our T will be equal to 120 sine 60 degrees, the whole over sine of, when we add that we get this is going to be 163.9. So we give our T 4 decimal places. So I'm getting 374.7478 newtons. So that's how we get that. That's how we can handle that number. So that's it. Remember, always whenever you want these angles, use the the horizontal lines and then the vertical lines. That's when you can easily see that. So that's it. I wish you well.